here's a paradox for you and me, one that challenges our perspectives as humans. Running or hiding isn't an option. We must face it. A paradox is an apparent contradiction. It's not an absolute contradiction yet. But there has to be an explanation if we want to get out of this one. And there is. This physics paradox can be resolved assuming there's an underlying material. We have all learned about a man named Einstein who proposed the theory of general relativity to explain our world. And to this day, all the scientific evidence we have gathered has only served to confirm his ideas. I'm not going to prove him wrong here. I'm going to show you that what he did was explain our predicament. We are limited to our perspective. We have no choice but to make distinctions. The scientific method is bound by its distinctions. The measuring machine is bound by its perceived shape. That perspective is valid and inevitable, but still a perspective. Hold on to your hat. It's going to be difficult. Let's begin with a few things we measure and how we explain them. If we have a photon on Earth with a particular frequency and send it to outer space, in outer space we measure its frequency to be lower. We call this a redshift, and we explain it by saying that the photon has lost some of its energy in the gravitational field. Its energy is h times nu, or Planck's constant, times the photon's frequency. The photon's frequency, nu outer, is smaller than nu on Earth. One of the earliest experimental verifications of gravitational redshift was conducted by Pound and Repka in 1960. They used gamma-ray spectroscopy to measure the energy shift of gamma rays emitted at the bottom and detected at the top of a tower. We have also measured time dilation in atomic clocks. Clocks tick faster at higher altitudes. More time units, like seconds, pass when the clock is higher in the sky. When the clock is moved back to Earth after a while and compared to its twin, the clock is ahead of the twin. It has ticked off more seconds. We have to compensate for this difference in our GPS systems to stay accurate enough about positions. The principle that makes the clock work is that, by a feedback loop, an oscillator is tuned to a stable atom's difference in the two energy levels, a resonance frequency. The oscillator is then used as a timekeeping signal, a clock. The atom gives off photons with higher energy and higher frequency at higher altitude. We do not know what the exact change is of taking the complete measurement apparatus from height 1 to height 2. What we do know is that measurements with spectrometer and clock show results that of higher position lead to the conclusions redshift of measured photon and faster running clock. Here's the thought experiment. We assume that a photon, like an atom, can be a clock. After all, the photon has a frequency itself. It oscillates in time, and this frequency can be used to compare to other oscillating stuff. Again, this is a thought experiment. Suppose we have 3 identical photons on Earth. We keep one, number 1, as a reference photon and send the others into space. We call the clock photon number 3. If we assume all clocks tick faster at greater heights, this photon will also tick faster. In other words, its frequency increases, so the photon is blue shifted at greater height. Its identical twin travels along. Its identical twin is photon number 2. They are identical, so photon number 2 must, by thought experiment, also have a blue shift. This would align with the notion that space-time is less stretched at greater distance from a mass. It aligns with general relativity. Smaller wavelength, so faster frequency, so blue shift. Now, suppose you bring photon 3 in a slower moving clock device up to height 2 and keep it there so number 2 passes number 3. Because clock with photon number 3 ticks faster, more ticks go off than on Earth while number 2 passes. To keep in line with real measurements from other clocks, number 3 must conclude that number 2's frequency has decreased because its speed is the speed of light, but more seconds have passed between maxima of the wave. Conclusion from the measurement is that photon number 2 and 3 are no longer identical. Now, here's the question. How come number 3 and number 2 are different at height 2, while they both went from height 1 to 2? Only because we call number 3 a clock does the difference exist. This is the photon paradox. It's an apparent contradiction, not a real one, because that would destroy reality. Reality just is, and still is. A question to ChatGPT. How come a photon frequency is red-shifted when closer to a mass? Gives the answer of ChatGPT. The redshift of a photon's frequency when it is closer to a massive object is a consequence of gravitational time dilation and the curvature of space-time, as predicted by Einstein's general theory of relativity. The negation of the same question to ChatGPT, how come a photon frequency is redshifted when going away from a mass, is answered by ChatGPT. When a photon moves away from a massive object, it can experience a gravitational redshift. This redshift is a consequence of both the gravitational time dilation and the change in gravitational potential as the photon moves to a region with a weaker gravitational field. In other words, ChatGPT, like us, struggles with the subject. If you were to build a clock from an element, let's call it cesium, that has energy levels with exactly the difference that produces photon number 3 at ground level, and send this clock into space, then at the new height, that element would produce a blue shifted photon. This clock, as would a spectrometer, would measure a redshift in photon number 2. Current physics has no exact knowledge on what height does to the space-time dimensions of the ensemble of photon 2/clock/photon 3. Current physics separates in experiments the measuring system from the rest, and separates on paper the measuring system from measured system and the rest. Current physics does not explain a difference between photon 3 and photon 2, except that photon 3 was called a clock from our perspective. From photon 3 perspective, it wasn't able to tick or measure photon 2, but it can conclude, which it doesn't, that it is still identical to photon 2. In current physics, this seems a paradox unless someone can resolve it. From a physics with an underlying material, the paradox seems resolvable, simply because it makes the photon's perspective more real than the human or machine or scientific method perspective, which are all the same perspective. The photon's perspective is called more real because, in reality, by conjecture, there are no exact photons or apparatuses, and there is only one speed of change, and that is the speed with which photons, as we perceive them, move. There is just one changing material, being reality. Less stretch in that material, called spacetime capital, or of its deferred Einstein spacetime, gives shorter wavelength and thus blue shift for photon numbers 2 and 3. They remain identical. The red shift is because of a relative behavior of perceived photon 2 and perceived measuring apparatus photon 3. Very real from their points of view. And there you have it, the photon paradox in current physics, and why we should, to perhaps resolve the paradox, do the experiment from the book mentioned in the description below.